Recording. Yes. Okay. She has led the Kingston University team in national and international research projects funded by the European Commission. Optimics Concerto, Quality of Experience Net, QualiNet, UK Research Councils, British Council, Royal Society, Innovate UK, and International Industries. She is an IEEE senior member, associate editor for IEEE Signal Processing Magazine from 2018 to 21, and IEEE associate at IEEE Transaction on Multimedia, associate editor as well. She was lead guest editor for the IEEE special issue on quality of experience aware wireless multimedia systems, and editor for IEEE Journal of Biomedical and Health Informatics, IEEE Multimedia International, Journal on Telemedicine and Application. She's an expert evaluator and panel member for the European Commission and National Research Councils, EPSRC and MRC in the UK. She was the editor from 2008 to 2010 of the Strategic Applications Agenda on mobile health and inclusion applications in the e-mobility, European Technology Platform. She's part of the Network 2020 ETP Expert Group and a board member of the Video Quality Expert Group, member of the IEEE Multimedia Communications Technical Meeting, having served as vice chair of the 3D Rendering Processing Communication Interest Group, and a key member of the Quality of Experience and Multimedia Streaming IG. So please welcome Professor Maria Martini. Thanks for coming. Please share your screen, Maria. Thank you.
Thank you for the very detailed introduction. So I'm going to share some thoughts and some notes about the quality of experience for light field imaging, in particular based on the experience we had in Kingston University. And I will also mention something about the relevant standardization activities within IEEE. Can you hear me properly?
Yes, perfect, Maria. Thank you.
Okay, I heard something. Okay. Oops, sorry. Seeing the attendance, probably we don't need these definitions. So this is just a definition of quality of experience as defined within QualiNet and now in ITU recommendation. Some notes on how to measure the quality of experience. I would say the golden rule is to perform subjective tests, and there are a number of recommendations to perform subjective testing. I listed here a few from ITU. Or we can do some measurement based on physiological parameters, for instance, AG, ECG, or pupillometry, electrodermal activity, to get information on the subjects, for instance, engagement with the content and enjoyment of the content. Or we can use objective metrics as models. Typically, they are categorized in three main categories based on the information which is available on the original content. I will focus in this talk on the subjective part, so the first part here. And in particular, I will focus on light field imaging. What is different in the case of light field imaging with respect to classical subjective tests? So first of all, the displays. In the case of light field displays, the points where the light rays hit the projection screen are not in a regular grid as typically for 2D video. Also, there is a specific angle, which is the viewing angle of the display, where the viewers are supposed to observe the image. And within this viewing angle, the content changes depending on the position of the user. And the user should perceive a continuous horizontal parallax in the case of horizontal parallax displays, or full parallax in the case of full parallax displays. I have here some videos, but probably in the interest of time, I will show only the last one. Just to show for those who are not familiar to visualize content on light field displays, how moving in front of the displays, the content that we visualize changes. So this was taken recently in our lab. So for subjective tests, you can see that it doesn't make much sense that the user stays in a fixed position in front of the display, since in this case he or she cannot perceive how the content changes based on the angle of viewing. In terms of subjective quality assessment for light field imaging, many of the tests done today, including most of the open access data sets, report subjective results after visualization on 2D displays, or in some cases stereoscopic 3D. There is a review we did on this that will hopefully be out published soon in a journal. And however, the problem is that the experience is different, as you have seen. So providing scores based on a 2D displays is not necessarily reflecting the experience or the visualization on a light field display. As we mentioned, in this case, it is important the user position, or the ability of the user. If there are multiple users, they visualize different content. Also, the content and the type of visualization is new. So it is important that the training is appropriate in this case. We presented some of these considerations in a recent paper that you can see below. Considering the subjective quality assessment actually done on light field displays, I reported here, we reported in this paper a list of the subjective tests done, and together with information on the weighting scale considered, the methodology, the display, and so forth. Many of these tests have been done in the framework of the QANet European project funded by the European Commission in the Horizon 2020 framework. And actually, those who are in the area probably will recognize as the first authors of the papers, the PhD students in the network, Peter Kara, Rupak Tamboli, Subbareddy Dakumalli, and also Aaron Cherkassky was in an ATN we were collaborating with. So you can see the variety that we had in the weighting scale, in the methodology that was used, in the selection of the viewing distance, and also the limitation in the type of displays used. So most of these displays are displays from Holographica, some of them are for 3D cinema. And very few of these, I think only one of these provides the results of the subjective test as open access at the moment. We are now producing new data sets. Maybe I can mention it. I can mention this later once we have identified the lacks of existing ones. I'm presenting here one of our studies. It was not easy to select which one to present and summarize, but I think this one has some interesting results, some interesting conclusions. So this is about the interdependence of spatial and angular resolutions for the quality of experience of light field. So how the reduction of spatial resolution is not necessarily bad in the case of reduced angular resolution. I will use these definitions here. So the angular resolution is referred to the number of views in a specific field of view. And the spatial resolution is the spatial resolution of the images before rendering. So as I mentioned, we investigated how the reduction of the angular and spatial resolution affects the perception of the quality and the perception of each other. So just to summarize the key effects of reduction in angular resolution and spatial resolution. Reduction of angular resolution typically results in crosstalk effect. So the adjacent views interfere, and when we have the rendering, the effect is, I will show later the effect that we have. Or we may have jumps in the views. So if the user moves in front of the display, there is no perception of continuous motion parallax, but there are jumps between the different views. If it is the spatial resolution which is reduced and is insufficient, then this results in blur, and in a blur which is not uniform in the displays, because as I mentioned earlier, the light rays hit the displays in irregular positions. So what we hypothesized and actually observed is that when the horizontal motion parallax is disturbed, so when we have a reduced angular resolution, a reduction of the spatial resolution is not bad from the quality of experience point of view, but it can even improve the quality of experience of the users. And we did some experiments. We considered 3 different spatial resolutions, 3 different angular resolutions, which in a 45 field of views are 135, 45, and 30 views. We did a pair comparison considering a 7-point scale. And the reason for the 7-point scale in this case is that we wanted to assess also slight changes, slight preferences, small preferences of the users. Then we considered pairs for down switching temporal resolutions. So we have 3 spatial resolutions, so 3 pairs for down switching, 3 angular resolutions, so in total 9 comparison pair stimulus. We consider 8 source stimuli, and we consider the holographic display, the C80 light field cinema system. In this case, we had 22 test participants. In this case, the question was not to assess the quality in general, but we asked the viewers to rate the smoothness of the horizontal motion parallax. This is an example of the content, and this is an example of the effect of the reduction of the angular resolution. So here we have the reduction to 80 views on the left, up to 20 views on the right. Here are the results. I had to cut it a bit short considering the time. So we have the comparison score in the horizontal axis, where 0 means no perceived difference. 1 means slightly better, -1 slightly worse. So we can see that in the case we have 135 views, the reduction in the spatial resolution is in many cases not perceived or not perceived as bad from the users. So most of the users provided the score 0, so no difference. And more users provided score 1, so improvement in the performance with the reduced spatial resolution, then the number of scores, the percentage of scores that provided a score -1. And this is more evident when we reduce the number of views. Reducing the number of views to 45, we have that the score 1, so slightly better, was the percentage of the users that provided score 1, so slightly better, was higher than those that didn't see any difference. And this effect was also present with 30 views, also in a minor scale. So I thought it was interesting because also for the considerations for the development of quality assessment metrics, objective metrics, this is an interesting effect that should be considered. And of course, visualization on 2D displays, as often done, or even on stereoscopic displays with 2 views, does not necessarily represent this effect. I added here a section on which is not specific for light field, but that we propose to use for the subjective quality assessment of light field imaging as well. Typically, subjective tests are performed with a number of users, 20 users, and then the mean opinion score among the users is calculated. But our actual aim when we perform subjective testing is to estimate the population mean opinion score. So we would like to calculate the mean score of an extremely large number of users that we don't have available, of course. At the most, we consider the mean opinion score based on a small number of subjects as estimation of the population mean opinion score. We have observed, however, that the mean opinion score is not necessarily, is not the best way to estimate the population mean opinion score. And we propose the model to estimate the population mean opinion score. I will not go into the details of the models, but in any case, what we propose is to make sure that in subjective studies, not only the mean opinion scores are reported, but all the subject scores. And this is because if we have availability of a complete set of data, so subject scores of all the subjects on all the contents, we can exploit all these information, so all the correlations between the values that we have, and we will get information on the different subjects, on the subject bias, and the difficulty in assessing some content, and all this information can be considered for the estimation of the population mean opinion score. So for instance, some methodologies that can be used, some methods that can be used to report the results are presented here. So an example are the spaghetti, what is called spaghetti plots. I'm Italian, but it's used internationally, not just by Italians. And so this is an example of the scores provided following the subjective test for the video game CSGO. For 3 resolutions, we don't care about the resolution now, we just call them ABC. And we reported as the spaghetti in the plot, the scores of the different users. So this basically these lines, these spaghetti lines, link the points with the scores of the different users. So each line is one user. So we can see here how the different users provide different scores on the different contents. So in the horizontal axis, we have the different bit rates. So ABC, as I mentioned, are the resolutions. In the horizontal axis, we have the different bit rates in megabits per second. We can represent this information in a different way. So in heat maps reported in the center. So we have the same axis, so score in the vertical axis, bit rate horizontally. In this case, we reported the histogram with colors. So the number of views, for instance, on the bottom left part, we have the number of views that provided a score 1 for the content at 600 kilobits per second for resolution A. And this is also a nice way to visualize the statistics of the scores and not just the most. Another way to report the results, which we found interesting, is the one on the right here. So we have on the horizontal axis the percentage of consistent scores. We defined consistency in a special way. In this case, since it was the case of compressed video at different bit rates, it was quite easy since we expected a monotonous curve for the scores for the quality. So our definition of consistencies was related to the monotonicity of the scores. So in this plot, for instance, we reported the scores of the different consistent scores of the different subjects in percentage by ordering the subjects in the vertical axis from the subject with the less consistent scores to the subject with the most consistent scores. So we can see that even the subject with the less consistent scores, with above 70% consistent scores, can be seen as a kind of prosecution as part of the curve of the consistency also provided of the scores provided by the other subject. Here I provided some examples. You can find more details in the paper on the right. I provided some examples of the estimation of the population mean opinion score. So we used an ordinary multinomial regression model for the estimation. So we have on the right the mean opinion score versus bit rate for the different resolutions for the CSGO content on the left, and on the right we have the estimated value again for the CSGO content and for three different resolutions. Here on the right, the confidence interval, of course, cannot be calculated in the same way as usual. So for the calculation of the confidence interval, we use a delta method. For details, you can see there, you can check the appendix of the of this paper. I would like to dedicate the last 2-3 minutes to understand they may be interested in learning what is going on in other standardization bodies. So I reported 2 or 3 slides about what we have done within IEEE standardization. The working group P323.1.4 has recently delivered recommended practice for the quality assessment of light field imaging. We submitted the first draft back in December, after addressing some comments which were mainly editorial. This went through ballot, and this was approved via ballot in August. So the final meeting for the transformation of the draft into a final recommended practice is in October, and so we expect its approval and publication in October. I reported on the right for those not familiar with IEEE standardization, the process to show where we are. And of course, the next phase for us will be maintaining the standards. So we probably have updates and a new version in the upcoming years. Just to give you some information on the content of the recommended practice, this is organized in 5 main areas. The first one on use cases, acquisition and visualization modalities, and also methodologies to characterize the content. We have a section on the influencing factors and the impairments. In the case of light field images, as shown in some examples, can be different from 2D typical images or video. We have a section on the subjective quality assessment, one on objective quality assessment, and the last one in data sets, where we provided a comparison of the existing data sets, some recommendations on the use cases for the different data sets. And we also provided a new data set from Kingston University, acquired with a way to explain optic camera, which is included and will be made public once the documents will be public as well. Some acknowledgements of the team members and colleagues who have worked at the papers that I mentioned. So Dr. Peter Kara was a former PhD student in Kingston. He's still with Kingston, but now also with a lecturer in Budapest. Kamran Javidi, Adris Shafi, 2 PhD students in Kingston, are the core team working on light field quality assessment. But I would like to acknowledge also Sergio Pexulli and Abhijit Marman, who contributed to the work I presented on the estimation of the population loss. In particular, Sergio contributed to the statistical analysis, and Abhijit Barman in particular to the subjective test and the gaming video data set. And of course, part of the work was done in the framework, as I mentioned, of the QINet International Innovative Training Network from the EU. Some references for those interested in reading more of what I mentioned. Actually, the second one is not published yet, but all the others are published. The first one is a draft at the moment and should be published as final recommended practice soon. That's all from my side. If you have questions, of course.
I think we have time maybe for one question here, if there are any. Yeah, so I think there's no question now, so I think we can have the Q&A at the end. Yeah, Kenya?
Yeah, I have a question. That's is that the library display available?
Sorry?
Is your library display available now?
What do you mean with available?
I mean, where I can
yeah,
buy
now it is. If you mean for subjective testing, yes. The good the good point is that we can start now. We bought this display, I think it was 2020, then we could not use it because of the reasons you all know. And now finally we have now planned all the subjective tests, the new subjective test, and we plan to do subjective tests in October and November. So now students are back to the university, so we have many subjects that can participate in the subjective test. Our lab is accessible because our lab is a special lab with no windows since we need to control lights. So it was not accessible during the COVID time because of this fact. But now, yes, now it is available, and we can go ahead with the next round of subjective tests finally. And this is the display. The one we are using now for the test is the one that I have shown in the video before. So this is the Looking Glass Factory one.
Okay.
Thanks.
Fernando.
Yes, Fernando.
Hi, Maria. I'm Fernando.
Hi, Fernando. Nice to see you.
How are you? Thanks for the presentation. Just a quick question. Do you have a requirements document that somehow has driven this effort, where somehow you define the objectives for the objective and subjective
yes,
assessment?
I have the scope. You mean the IEEE one, or?
Yes, for the IEEE recommendations,
yes,
is there a requirements document?
I think I have this code, but probably I cut it. Let me check if I have this slide here, because I had too many slides, so I cut a few of them. I have the scope in the previous version.
Mm-hmm. Is the document public or?
The scope is public, yes. Maybe I can send you the link.
Well, maybe you can put it in the chat and we can see it.
I can put the chat in the link. Let me
Okay.
do it
Thank
now.
you.
I can do it right now. But
Okay, thank you.
If you type the code P333.1.4, you should be able to see it. Okay, here it is. Yes.
Okay, thank you very much. That will be very useful for us.
Yeah, thank you. Okay.
Thank you.
And it is.
Okay, thank you, Maria.
Thanks, Fernando.
Yes. So our next speaker, Dr. Jibo Chen. So Dr. Jibo Chen is currently a professor in University of Science and Technology of China and the director of Intelligent Media Computing Lab. He formerly held the position of principal scientist at Thomson Research Innovation Division. His research interests include visual signal representation and coding, visual signal quality assessment, and analysis. He has more than 150 publications and standard proposals and over 50 granted EU and US patent applications. He is currently serving as the chair of IEEE Visual Signal Processing and Communications Technical Committee and associate editor for the IEEE transactions on circuit and system of video technology. Professor Chen, the floor is yours. You can share your
Okay, thank you, Saeed. Let me share my screen. Okay, can you see my screen now?
Yes, we can.
Okay, okay. Hello, everyone. It's my pleasure to be here again. And actually, my group has done some research work on the light field image quality assessment several years ago. So I'd like to share some of them, and most of them have been done around 2 years ago. So this is the outline of today's presentation. First, I want to introduce one of our work on the subject database design, and including how to select the SRC and HRCs, and how to design the subjective evaluation schemes. Because when we designed this database, it's around 2017, and at that time there's still no mature light field displays. So we need to solve the problem to provide some light field experience for the subjects. And based on this kind of data set, I will introduce two of our research work on the objective light field coordinate assessment model. Okay, so why light field is important? I think in last workshop, we have also some discussion on this. We can see that from the black and white photos to the metaverse using advanced image and video technology to enhance the user experience and the immersion is already trend for of the multimedia technology. So I think light field technology is one of the key technologies which can provide 6 degrees of freedom, immersive experience, and it's very important for the many future media applications. Since light field image record light directions, information, so light field image can provide a unique viewing experience. So like this video shows, we can see that the light field can provide a full 3D sense, and including the stereo parallax and moving parallax and the refocusing. All these kind of dimension will influence the user experience. So if the rendering algorithm is used, it can also further provide a complete 6 degree of freedom experience. And finally, the depth information of the scene can also be derived from the light field content. So many traditional vision tasks can benefit from such kind of depth information. So this can also make the light field more important for some potential applications. Here are some typical applications, including the industry surface inspection and light field microscopy, to generate some special effects of preview videos for entertainment applications. So regarding to the coordinate assessment of light field, it's very important to generate a light field coordinate assessment data set at first. So this work, I think we started this kind of work from 2017. And at first we need to select some very typical light field content. When we start this kind of building the data set, we select six content from the literature images with a very dense parallax, and 4 images from the synthetic images with larger parallax. And also we calculated their special index and the colorfulness to try to select different representative content with different special index and colorfulness. And also considering the distortion types, when we're building this data set, we select 2 compression distortions for light field images and 4 synthesis distortions. The 2 compression distortion, we use the JPEG 2000 to compress a lens image with a compression ratio of the from 25 to 200. And also for the array of image formats, we use the HEVC to compress the procedure sequence with different quantization parameters from 24 to 44. This is the setting to generate the compression distortions. And to generate 4 synthesized distortions, we utilize 4 view interpretation schemes, including 2 schemes based on the convolutional neural network. And here, the number key is the number of views randomly selected to be synthesized. So the number can be from 24 to 44, just to simulate a different kind of scheme of the view synthesized. So based on all these kind of distortion types and synthesis distortions, we totally have 22 hypothetic reference circuits as shown in this table. So another issue is the display, because at that time there's still no mature light field display in 2017. And at that time, we still want to provide some using the more light field experience, like close to the 6 degree of freedom experience to the subject. So we use the 3D display, and we try to provide the stereo parallax to the subject with the 3D display and the glasses, and to change the view by using the mouse, and to provide a refocusing effect to the subject also by clicking the mouse. So we generate such kind of display software by ourselves, just like this image shows. And by using the very low cost 3D display and the subjective testing software, we can provide 5 degree of freedom to the subject. Because there is no forward and backward degree of freedom, because there's no, we didn't do any exercise algorithm in the software. And also at that time, the light field image we used is a very limited resolution. And we adopt the double stimulus scheme for the subject testing, and all the description of to generate such kind of database can be referred from this paper in 2018 ICIP. And as mentioned in the above slides, we use a double stimulus continuous subject testing to generate the quality scale. We follow the ITUT P.910 setting for the whole subject testing, and each subject is a request to provide 2 kind of score. First is their experience on the picture quality only, and then the second score is the overall quality. And because we try to use these 2 scores to evaluate the user experience on the picture quality and the angular quality. And we use the most score from 1 to 5, and totally there are 23 effective non-expert subjects used, and the total subject testing time is 90 minutes, and there are 5 minutes rest after 25 minutes testing. We selected 10 original light field image, as I just mentioned. There are 6 from literature and 4 from synthetic light field images. And totally, there are 22 HRC. So in total, there are 220 distorted images. And we also did some outlier analysis after the sub-testing to remove some outlier. And this figure shows the distribution of the picture quality of the compressed sequences, and this is distribution of the picture quality, and this is the figure shows the distribution of the overall quality of all the sequences. And we can see it's very close to the uniform distribution. This actually is considered before we try to generate the data set. We don't want to introduce too much bias in the data set. And from this figure, we can see that we try to analyze the influence of the picture quality and the overall quality. You can see for different HRC, the picture quality is always better than the overall quality. This means the picture quality cannot represent the quality of the whole light field images. At the same time, the picture quality declines with the overall quality when overall quality is dropping off, especially from, we can see from HRC 01 to HRC 10. And the correlation between the picture quality and the overall quality is around 0.76. And this means the picture quality really has some a significant impact on the overall quality, but it's still not the only factors. So another important factor should be the angular distortion, or usually caused by the view size. And we can call this angular distortion. We can see the here from the HRC 11 to HRC 20, there are serious angular distortion, and this leads to the low overall quality. This is because such kind of view size distortion can destroy the motion parallax and produce a noticeable distortion, like a frozen or something artifact. And this proves that the inherent properties of the light field image should be considered as an important influence of factors to the overall quality. So this table concludes some comparison with some existing data sets at that time. We can see this data set we generated can provide the view change effects, the stereo parallax and refocusing, and provide 5 degrees of freedom. And this is the first public available subjective quality evaluation data set that can provide 5 degrees of freedom at that time. And we also, at that time, we test some existing 2D and 3D image quality assessment schemes on this data set. And we can see for all these 2D or 3D image quality assessment scheme, we run them with default parameters. They're not retrained on this using this data set. And each view is computed separately, and we get the final score by averaging all the subnatural views. And the correlation between the mean opinion score and the predict result is computed using the SROCC, and we can see we use SROCC, PRCC, and PRCC and MSC, and we can see the best results are in both font. And for picture quality, you can see the SINQ. This work outperforms other full reference image quality metrics. And for no reference metric, the IWSSM provides the best results on the overall quality. However, there's still a gap between the existing metrics and the subjective quality rating. Since all these kind of 2D or 3D algorithm don't consider the intrinsic property of the light field images, especially the motion parallax and the refocusing. So therefore, it's very important to design some specific light field image quality assessment schemes. Okay, so therefore, after that, our group has have developed several objective models. I just here to give a very brief introduction. And this is one of our work to consider to measure the spatial angular distortion of light field images. As I just mentioned, the distortion in the light field image include not only the picture quality, but also some angular distortions. Considering that the light field image can provide some binocular perception, so we utilize the binocular fusion and the binocular rivalry theory to evaluate the spatial quality of light field images. And we propose the light field cyclopene image array, and to evaluate the naturalist as a metric to measure the distortion of spatial quality of the light field image. So this scheme can take advantage of the information from all subnatural images and effectively capture the global natural distribution of the light field image. And we in this scheme, we first try to simulate the molecular fusion and the rivalry to generate light field cyclopean image array. And then we analyze their naturalist distribution as shown in this figure. And we can see we use the MSCN mean subtracted and contrasted normalized coefficient to evaluate the difference of different distribution of the different distortions. And this figure can see we can see that they can separate the different distortions. And for the angular distortion measurement, usually they are caused by the view synthesis or view interpolation algorithm. And the distortion introduced is mainly because this kind of interpolation operation will break the angular consistency. So to measure such kind of distortion, we try to use the EPI message image, the epipolar plane image, because we try to extract the features from this kind of EPI image, and because EPI image contains the angular information of the light field image. And traditionally, we can see the slopes of the lines in the EPI image can reflect the depth of the scene captured by the light field. And the slopes of the undistorted EPI image can effectively reflect the depth and disparity information. And if we introduce some distortion by the view synthesis, we can see the EPI image can generate some artifacts in the slope. So it's very easy to draw the conclusion that we can find that the gradient direction distribution is very effective to measure the degradation of the angular consistency. So we propose some scheme like the gradient direction distribution and also the weighted local binary patterns to capture the relationship between the different subnatural images. And here, the LBP is very famous algorithm. It can be able to extract the local distribution information. It's very effective in many other works. So, and this figure shows there is a significant difference in the LBP distribution for different distortion types, as shown in this figure. So based on the above observations, the framework shown in this figure, we propose this framework in our work in the CSVT 2019. And the first, the synthetic cyclopean images, their naturalist is extracted from the subnatural images and the angular domain feature, and the gradient direction distribution is calculated from the EPI images. And the weighted LBP descriptor is also extracted here. And we fuse all these three features together with the regression model to get the final quality score. And this table shows the performance on the different dataset, including the Win5 RID dataset and MPI RFA dataset and the SMART dataset. It can be found that compared with the traditional 2D or 3D image quality assessment schemes, the proposed scheme has much better performance. So there's still some time. I can introduce another work. This is the second work on the from our group on the light field image quality assessment. Is considered from the decomposition of the high dimensional data, because as we know, light field image is kind of 4D tensor, but all the existing work ignores, didn't consider such kind of intrinsic high dimension characteristic of the light field image. So therefore, we try to use the tensor theory to effectively to describe the characteristic and the distribution of the light field image content. Here we use a tensor-oriented no-reference light field image quality scheme, which consider both the luminous and the chrominous effects, as well as the impact from the angular consistency and in the different directions. Here, the Tarker decomposition is used to decompose the 4D light field tensor into a set of metrics and one small core tensor, just as shown in this figure. So this is the framework of the work. Specifically, all the simulation images in the RGB format are first converted into the LAB color space because it's much better to approximate the color perception in the human vision system. And this LAB color space contains one luminous and two chrominous channel. And second, to comprehensively capture the degradation of light field image angular consistency, we use a view stack. Just as shown here, we use 4 directions of the view stack from the 0 degree and 45 degree and 90 degree and 135 degree of directions. And for this, all these kind of different view stacks are generated. And then we use the Tarker decomposition to reduce the angular dimension of the view stacks and obtain only the first principal component as the most important dimension of the whole view stack. And then we consider light field quality is affected by both the spatial quality and the angular consistency. So we propose the PCSC, the principal component spatial characteristic algorithm to measure spatial quality from 2 key aspects. Firstly, still the naturalist distribution of the individual and the mutual color channels are used. And another factor is the local frequency distribution is used to capture the local spatial quality degradation. And another factor we consider is to measure the angular distortion. We use the tensor angular variational index to measure angular consistency. This is computed by analyzing the structure similarity distribution between the first principal component and each view in the view stack. Then we fuse all these kind of features to regress to get the final quality score. Okay, so this figure we just show a sample from light field image, and from the image A to C shows the first 3 principal components of the first 3 horizontal stacks, and we can see that the integer mainly focus on the first principal component. We found that the first principal component contains more than 70% of the energy. So that's why we only use the first principal component for the quality evaluation. And for this figure, you can see that this is try to calculate the distribution of the principal component and to measure their naturalist, just as the first work we have introduced. And this is we design the tensor angular variation index to evaluate the angular consistency. And this figure shows we compare the SSIM structure difference between each view and the first principal component. And if we don't have any distortion, we can see it's very smooth. But if there are some distortion from the view synthesize, we can see there are different kind of curve can be seen from this kind of figure. And specifically as the angular consistency degrades, the variational degree in the structure similarity in distribution of the light field image increase gradually, and different distortion can have different such kind of shape. So we use this as an index for the angular distortion. And then from this figure, you can see if we consider the light field image as a 40 tensor and use some tensor theory to extract the features for the quality assessment, we can get much better performance on the quality evaluation. It's better than the first scheme I've just introduced. Okay, so as a conclusion, I think subject to evaluation scheme for light field images still very important. If we have very mature light field displays, as Professor Maria just mentioned, it's very good for the such kind of to continue such kind of work. And we need to consider the spatial angular distortion from the light field images. And there are also maybe in the future there are some possible new distortion types need to be considered. For example, for learning-based coding schemes or some other advanced view synthesis or view interpretation of rhythms. And another important factors for the quality assessment is try to improve the generation ability of the quality assessment model and also their explainability. Since we need to use such kind of IQ model to guide to optimization of the learning-based light field image coding or restoration. Okay, that's all for my presentation. Thank you.
Thank you, Professor. So we are a bit short in time, but maybe we can have one question if there are any. Okay, so I will introduce our last speaker today. Professor Patrick Lecalle received his PhD degree in image processing from École Polytechnique de l'Université de Nantes. He was an assistant professor and a full-time lecturer with the Department of Electrical Engineering, Technical Institute, University of Nantes from 1997 to 2003. He led the Image and Video Communication Laboratory CNRS IRCCYN from 2006 to 2016, and he was one of the 5 members of the steering board of CNRS from 2013 to 16. Since 2015, he has been the scientific director of the Cluster West Industries Creatives, a 5-year program gathering over 10 institutions, including 3 universities, and since 2017, he has been one of the 7 members of the steering board of the CNRS LS20 laboratory and a representative of Polytech Nantes. He is mostly involved in research dealing with applications of human vision modeling in image and video processing, and his current research interests include quality of experience assessment, visual attention modeling, perceptual video coding, and immersive media processing. Please welcome Professor Lecalle.
Thank you very much, Said. That was a long bio. I'm not sure you save a lot of time reporting this one, but anyway, thanks for the introduction. I want also to thank the 2 previous speakers, my colleagues, for introducing most of a very meaningful concept that will be also somehow being flavoring my that will flavor, sorry, my presentation. So. Thanks for the invitation, also the JPEG committee to this workshop, and designing this presentation. I was thinking what I can do considering the title of this workshop. So I could put, well, yes, we are going to discuss about JPEG Pleno on light field and subjective quality assessment. So and knowing a bit what JPEG is doing, a bit only. I thought it was interesting spotting the word subjective quality assessment to come back on some principle on the art of designing meaningful data set for quality evaluation of immersive multimedia content. So by meaningful, especially what are we targeting here? And I was thinking that what was mostly of interest for the JPEG community is to understand what type of data set to produce, how to produce this data set, and this will be quite in line what we have seen before from the two other presentations, and a bit also how we can qualify probes and metrics to do this job. So when we are talking about video quality assessment, and we could say Pleno or light field quality assessment, it's really a matter of use case. And I think it's really important to think about how we should specify and qualify our probes, respectively, if it's subjective or objective. And this can be a matter of use case. Are we targeting something to optimize the system at a local or global level? Local meaning, do we want a probe to optimize a codec inside the codec? Or do we want a probe that measures the result of a video? Another use case, and this is something usually done in JPEG, can we benchmark systems? And for instance, says that a recipe 1 of a codec is better than a recipe 2 of another codec. And once again here, things which are important to consider is the range of quality in which we are going to perform this benchmark, but also the use case, how this media is going to be exploded. So when it comes to designing a data set, to answer some of these questions, first of all, you have to well define your questions. So by data sets, I mean some render content presented to some observers, and it means that these contents plus the observer ratings about the quality. So we should really think about the purpose of the data set. Are we doing this data set to understand and better model the human visual perception? Are we developing this data set to benchmark systems? Are we developing this data set to qualify objective quality metrics? Are we developing this data set to design new objective quality metrics? And especially at the time of a learn-based approach, irrespective it's deep learning or anything else, how should you develop good data set to better learn the metrics? And thinking about this purpose, we should never forget neither the use case, how the media is going to be exploded. And I will come back on this later on, especially in the context of Pleno and light field. Just to give you some flavor, if we are talking about training objective metrics, there are few frameworks that show that already you can use existing data set to retrain your metrics, and you don't you can take advantage of all existing data sets produced so far, even if they are not on the same rating scale, if they are not using the same subjective procedure. There are some frameworks that help you to exploit any ratings that exist in literature. So there are few proof of concept of this framework, and that has been introduced by notably Krasula in 2019. And the question that you should raise is that if your purpose is to develop a new data set or refine an existing quality metric, you may wonder yourself what you should add another existing data set among, for instance, the 20 that are reported here. So the idea here is to extend this data set with conditions which are not existing in the current framework. It's a very important concept that has been introduced here, because usually what people do, they train on one data set and then test on another one. And this is another exploitation of the what we have on hands. And in this framework, it is really explained how to do that better. Another thing that I want to stress, it's also a work from Krasula and his colleague in 2016. When you want to qualify your tools, you may be interested to qualify the metrics according to the quality range. And for this, if you do that only with RMSE, correlation coefficient, and so forth, it might be not sufficient. So there are existing framework that allows you to actually qualify quality metrics according to some data set and according to quality range, the different range of mean opinion score, where usually correlation coefficients are not efficient. So about the art of designing meaningful data set, usually what we do, we are going to develop a test plan. Thanks, Maria, for introducing the vocabulary in your presentation. So if you look, for instance, usual VQuake test plans, we are going to discuss about how the source content that we're going to use, which are usually referred as SRC. Then this source content will go to what we call HRC, hypothetical reference circuit. Usually for 2D, these hypothetical reference circuits, and you may have many, will deal with pre-processing like denosing, downscaling, sensor error, and so forth, coding, transmission impairment, decoding, and eventually post-processing. Of course, you may have very simple HRCs that just take an source content and then encode it, decode it, and then as a result, you get PVS. So a test plan will define usually SRC, hypothetical reference circuit, and as a result, process video sequence. And this is the PVS that you're going to present to human ratings. So the key challenge that you have to address when you want to design meaningful data set is how to select your content, how to select the relevant HRC, and the previous presentation gives some insight about that. Of course, the relevant HRC is really use case dependent, so it's really the purpose of the exploitation of your test. Is it for metric development, benchmark, in which quality range, and so forth. You have to select the relevant PVS because you cannot test everything. So these are, of course, key challenges that you may you should raise, and you may need some tools and methodology to address these things. Plus, in addition to that, it's not the art of designing meaningful data set is not only about selecting SRC, HRC, and PVS, but also to define and boost the rating protocols, because any rating we're going to get costs. Another challenge that we have to face is to getting reliable opinion score. So it's all a matter of screening and, sorry for the typo, and cleaning the data that we get from once we ask people to give their opinion. And then it's also about specifying acceptable uncertainties and characterize these uncertainties. If we get opinion from people, we will get mean opinion score, and a mean opinion score comes with confidence intervals. So, and if we want to qualify probes, if we want to benchmark, we have to take into account these uncertainties when we draw conclusion, but also when we qualify quality metrics, and if we want to see if a quality metrics is well aligned with subjective score, we need also to take into account these uncertainties. So just to give you some insight about characterization of source content, there are some methods which has been proposed for 2D, for stereoscopic 3D content, for high dynamic range, wide color gamut, and so on. So you can better characterize your content and just not only take the content which are available for research or whatever. So there are, let's say, frameworks that helps you to better qualify your content. And this must go beyond just spatial information and temporal information, especially if you touch stereoscopic, HDR, or even light field. You need to invent how to characterize your content. Just to give you some insight and to go briefly on that, also to qualify your uncertainties. This is something that you may also tackle and understand what is the discriminability of your test. And for this, there are also methods that help you to, notably one developed on MLE quality recovery model that helps you to remove the noise from your subjective data and limit the uncertainties that you could get from a mean opinion score. So there are very advanced statistical tools that helps you to do that. And that can, for instance, help you to estimate uncertainties, the bias of each subject of your panel, and the inconsistency of each subject of your panel. Eventually, you can use that to remove some panelists, or you can use this also to clean up your data without removing, but just estimating the level of noise and better recover your score. So another thing that I want to mention, because any rating cost, you may also try to boost your ratings with active sampling methods that helps you from existing scores that you have already collected, better identify what is the best condition to be tested and presented to the next observers. And I'm referring here to one of the work we did a few years back, introducing hybrid MST. This is really about this ID, but developed for pairwise aggregate preference protocol. But there are similar approach for ACR, DSIS, and so on. So the idea is that you start to collect data from the crowd. It can be from crowdsourcing experiment or for in-lab experiment. And as you collect data, you can think about the next playlist that you should present to the next observers, so you can maximize the information that you're going to get, and having in mind that basically what you are seeking for is limit the uncertainty. So try to focus the experimental effort where you don't, when you don't reach the discriminability that you want to reach. Well, when it comes to light field, Pleno, 360 volumetric video, we have to deal with a new challenge also, especially because we have to take into account interactivity and various rendering possibilities. In the first talk, Maria was introducing that we can do light field test on light field display, letting the people freely navigate in this condition. But there are other ways also to test that, where you can, for instance, render your light field and playing with the parallax and just generate a 2D video like it is done on the left-hand side of this slide. You can also do, because of light field, you can also exploit the possibility to do refocus and defocus of put everything in focus, or play with artistic art, and you can also generate pseudo image, pseudo video of this refocusing, defocusing approach, like what is presented in the middle of this display. The same applies for let's say a volumetric video where you can play around and so on. So the question is that, do you let your observers play with that freely? Do you constrain that? Do you provide some kind of a pre-calculated trajectory and so on? Thinking about that, we can extend the traditional approach of test plan. And why before we had SRC, HRC, and PVS, we had to add something more in the loop, which is HRT, hypothetical rendering trajectory. So this hypothetical rendering trajectory may reflect possible interaction of the end user with the content, could be focus, defocus, could be full parallax, could be many things. You can let your end user panelist play, freely interact with the content, or you can constrain that and present pseudo video or pseudo image, which are reflecting possible rendering trajectories that may happen. So, of course, if you said that, key questions that happen, how should you select your hypothetical rendering trajectory? In the case of when you let your observers freely interact with the content, how many observers do you need to reflect the possible all rendering trajectories that can happen, taking care of the interactivity? So this term of hypothetical rendering trajectories in framework has been actually introduced in this paper. And in addition, in that paper, there was also some proposal to identify the most critical hypothetical rendering trajectories, and that might depend on the use case. So suppose you have a light field or let's say volumetric. Let's take the example of volumetric content. What is the most critical rendering trajectory, the most critical way to interact with the content that will exhibit the worst case scenario, which means depending on the, for instance, of compression, the scenarios that will introduce more perception. So Another thing that I want to mention also for source content, there have been some effort also to characterize and select light field SRC. So you see a few works existing on how to select SRC and also on how to select HRT. We have seen in the previous talk how, some techniques to select HRC, but another thing that we need to consider here, what are we going to do with HRT? Just to supplement that a little bit, this has been done, for instance, for the HRT, for just exploding the horizontal parallax, and this has been introduced also how to select critical trajectory using the full parallax. So you have some reference here, and it's for your record. One thing I want to mention here is that this approach has been used actually in the development of light field distortion on the EPI. So thanks to the previous talk, you know all what is EPI, and it has been developed for a non-reference quality evaluation. So I know it was not the focus of this presentation, but just to let you know that this work has been done. So it's a different approach compared to the one that has been introduced in the previous talk. But using a few data sets, the metric operates in the epipolar plane, and it's a non-reference metric that use some kind of convolutional sparse coding techniques and also bag-of-word feature selection, and which is able to improve the result of the quality. So I just want to illustrate, it's not about light field, it's not about volumetric content, but I'm going to select on purpose something different, but how we can apply all these tools to define and promote and find a good data set, but in the case of high dynamic range. And now you can identify, for instance, challenging content or challenging conditions. So the problem here, the problem here is to find the best tone mapping operator given high dynamic range content. So you have here some different results of a tone map version of a HDR content, and you can see that they can lead to very different results. Here we are not going to record the result in terms of quality, but in terms of preference. So you can form all of the possible pairs and ask the observers not to express the quality of experience on a continuous scale, but to express their preference of experience, POE. So which one do you prefer among this possible tone map version of an HDR content? So one question we can raise is that if we want to collect data at scale, can we use crowdsourcing to measure POE for tone map image? So we know that crowdsourcing is very useful. It has been powerful, especially in the days of COVID, to perform a remote experiment. But if we go for pair comparison test, and which is the underlying ground truth of preference of experience, we have some challenge because there are lack of standard and guidelines for this type of study, and we don't know exactly how to screen people. So we have investigated all these things. We have validated that using different data sets, running experiment in the lab, experiment online with the same observers, experiment online with non-control observers using notably prolific platforms. And out of this, we could identify if there is a hope for to perform experiment online with uncontrolled environment as uncontrolled observers. We tried also to identify how many raters you need as we start to play with uncontrolled condition and uncontrolled observers. And this type of figures, which are appearing in the paper that was mentioned before, tells you basically you have a measure of certainty, the number of pairs in your data set for which you can confidently say that there is statistical difference between the two conditions. So this number of pairs will where you can reach this statistical significance is of course depending on the number of observers that you are using. So as you increase the number of observers in your experiment, you will gain in this discriminability, but also it differs depending on the type of condition you are using. So are you in full control environment with full control observers? Are you in the condition in yellow, full control observers, but uncontrolled viewing conditions? Or are you in the case of purple in uncontrolled condition as uncontrolled viewers? And you can see that if you want to reach the same accuracy or discriminability of your test, as you are distorting your condition, you need to increase your number of observers. But at least with this type of experiment, you have some recommendation and guidelines on the number of observers that you need. Another key challenge that we tried to address is that can we measure the reliability in pair comparison paradigm, especially when we are in touching uncontrolled observers? So how can we detect that in crowdsourcing an observer is a spammer? So we develop a few techniques to do that in addition to screening question, and especially we have shown that Roger Tanimoto dissimilarity is a useful tool that can help us to find some once we compute this RT dissimilarity on various observers, find some threshold to remove some kind of a spammer and then remove some raters from our experiment setup. Okay. Then still going on that front. So once we had all these tools for performing crowdsourcing experiment, cleaning data, screening people, we were thinking how we can build a large-scale data set and how we can select our content, but most importantly, how we can select the most relevant process video sequence. In that case, it was image, but still the same idea. So, and we have in that study, we had two main goals. Why we wanted to produce this large-scale data set was first to have a representative and challenging data set for benchmarking existing objective quality metrics related to HDR tone mapping operators, but also to develop new metrics with learn-based approach like DeepNet. So that was our goals, and this drive mostly how we select SRC and PVS. Let me give you some ideas how we did that. So first of all, the problem with HDR, we don't have that much data set, so we had to go through data augmentation and with some kind of feature selection to tell us once we do this data augmentation, how we can qualify a source content. And now, when it comes to PVS generation, what we did, we look at how existing quality metrics are reacting to various tone mapping operator. And we try to sample all this space according to the metric and find some condition where, for instance, there were some image easy to tone map for all the tone mapper, and some condition where, according to the metric, there were some tone mapper that were easily that provide good quality, while some other were provided bad quality. So providing this type of space help us to select the content and, most importantly, the PVS, the tone map version in for our experiment. So the same could be applied for PVS and so on. Just to give you an idea, to validate this approach, to validate our SRC PVS selection, we could once we run the experiment, using many HDR, many TMO, many pair comparisons, 70 observers per pair comparison, 3,500 participants, we could see how we could validate this a posteriori, that this approach to select challenging content was kind of meaningful. On this front, I could refer also to other readings on similar approach related to mesh content, where you have also to deal with some kind of interactivity and so on. And here, the idea that could serve also as an inspiration for a JPEG test plan is that suppose you have a minimum subjective data set, you can fine-tune some existing metric. Here, in that case, we were using HDR-VDP and LPPIPs. We can fine-tune them based on a pilot test. And this is what has been done here. So for some match content, we have already a data set. We fine-tune existing metrics according to that. And then we generate many PVS. And we are able to plot all these PVS in this 2D space where we are using our fine-tuned 2 metrics. And then the idea is to sample all these PVS samples here in black with few samples in blue that will help us to design the PVS that we select for our experiment. And having this in mind, that it's good to have disagreement between metrics, existing metrics. When we have disagreement between existing metrics, this is probably where we have to test to know which one is right or wrong, and eventually develop new metrics that will take advantage of this new data set that we're gonna develop. So you see here, the idea is to use existing metrics, fine-tune them on very small data set, and then from this find the challenging solution using this kind of framework. For sake of time, I'm not going to describe that, but you can refer to notably to the first paper to understand how this thing has been done. And I think this is something you can readapt easily in a test plan in JPEG. There are other suggesting readings that I can suggest to you on how you can detect a spammer in crowdsourcing, how you can characterize the perceptual characterization of content and going beyond SITI, especially for 3D graphical content, and which is not that far from a light field. And also how you can boost pair comparison protocols, notably with this recent paper. Okay. Another thing that I would have loved to touch with you, because I know that JPEG will be interested at one point of time, but quality metrics, computational complexity of quality metrics is also challenging these days. And I just want to refer to that study without giving too much time to this. But in this study, it has been studied the effect of temporal subsampling and temporal pooling on the accuracy of volumetric video quality assessment. The idea is, can we reduce the computational complexity of the metrics, processing less of the content? So if you think about light field, should we compute the quality metrics on all the light field, or can we gently sample that so we without sacrificing too much on the performance? So I'm not going to describe that study. So in conclusion, yes, I just want to draw your attention that a preference of experience can provide many advantages, even if I did not fully cover that in my presentation. But the art of designing, collecting data set that promote challenging content is a key issue. And this is really something important to consider when you develop test plans. And there are more and more and many method approach to quantify this. And another thing that you could look at also is that another concept that has been recently introduced, notably in San Diego, is this concept of satisfied user ratio. And how can we measure that and predict that? It's another very interesting topic, but some food for later discussion. Thank you very much for your attention, and I'm open to any question.
Thank you very much, Patrick. Thanks a lot, Maria and Zibo. I'll ask you guys to open your cameras, please, to start our question and answering. Thank you. Thank you. Thank you. I have a question for all you guys, actually. There is a say in broadcasting that says that content is king, and all you guys talk about the data sets, which is true. The question is how to achieve the diversity on scene geometry to the different use cases. For example, telepresence, you need the sense of presence. You need life-size objects to really give the sense of presence. If you target medical applications, you need precise, very precise data, because people are going to grab a scalp and cut you, or to analyze a tumor or anything. And the gaming, you need the diversity of scene geometry to provide that sense of metaverse or whatever. How do we achieve this? It's quite challenging task.
Yeah, the first answer that comes into my mind is that it is not just the content that we select, but also the way we select to capture the content. For instance, you mentioned the medical case. In this case, we will need to use really a plenoptic camera, or because we need very detailed information, as you mentioned. For other contents, for instance, we would need to use arrays of cameras which are more distant from each other. So even the way we capture content, the number of cameras we select, the distance between the cameras, has an impact and should be related to the use case. It's not just the content of what we acquire and what we include in the data set. It's also the acquisition method and the parameters for the acquisition.
Yes, the same geometry, if you have an object closer or farther away from the camera, yes.
Yes.
I think this is what I try to touch in the presentation. It's really a matter of use case. If you think about, let's say, MPEG test, you have category of content, right? And you could say, okay, it's graphic content or whatever. But usually the way the content are selected is very qualitative. But they correspond to specific use case. So, of course, with light field and Pleno, you are exploding the type of use case, but also the dimension of QoE that you have to touch, and the feeling of presence. In the studies that I mentioned for mesh and volumetric, graphical volumetric video, actually one feature to select content is really related to the geometry of the geometric complexity of the graphical content. So, usually in 2D, we were considering temporal information and spatial information as feature to qualify a content. Yes. Then when we started to move to HDR, wall color gamut, we should add probably color information, gamut, dynamic range of the luminance. If we move for 3D content, you may, let's say, consider features like number of occlusion or percentage of pixels that can be occluded. So there are many features that you can consider like that. And once you want to select your content beyond the use case, it's not graphical or gaming or whatever, you could extend the set of features that you are considering and cluster your source content in that multi-feature space, which is not longer a 2D feature space. 2D in a sense, spatial information, temporal information. It's ND features. And that's probably the way you should tackle that. But I must confess that most of the studies that has been done so far, and in some standard, the big constraint is availability of content to work with.
Yes.
And nevertheless, you should quantify and qualify this content, even if you don't have that many, because it may end up that you may miss some part of this ND space.
Yes.
And this is where you can make really call for, I would say, a kind of a call for content, right? That have these particular features and open content so we can work with to develop the standard.
Yeah.
Maybe I can mention that we plan to make available soon. We have realized we haven't published it yet, but we plan to make available soon a data set with different levels of transparency, because this also has an impact in light field.
Excellent. It will be public available?
It will be publicly available once we publish it. So the data set is ready. The data set is ready. No, I mean, we want to publish the paper first. So once the paper is published, the data set will be released. But yes, this will be publicly available.
Okay.
It's
Thank
good
you.
you put it on the table, Maria, because even in a graphic community, this is one of the most challenging case. Also, this type of content. The reason why I'm referring also to graphic community is that I think that light field, Pleno, volumetric video, and so on is somehow a way to merge the effort that has been done in video processing community for an image processing community for years and graphical community. And it seems that now we have a convergence of effort of the community, of both communities on this. And that's very insightful to look what has been done in graphics community too.
Yeah, sure. Any other thoughts? Or people can raise their hands or jump into the discussion. Please do. I cannot see any hands because but please do ask. No other questions?
Maybe I ask a question here. So we talk about the content, but also the way that we are doing the subjective experiment. So we see in the talks that there are like methodologies to do the test, but considering like both special artifacts, like the coding artifacts, and also the smoothness, which is in the angular or parallax domain. So there was a in one of the talks there was a experiment that was only concentrated on the smoothness, for example, right? So do you think that we still need to do them separately, or we can like have a mix score or mixed opinion on both like the special artifacts and the temporal artifacts together? Yeah. Or do you have like ideas how really we can have the real, let's say the real 5 degree of freedom or 6 degree of freedom subjective experiment, and give the scores with high discriminability and high reliability?
Yes, you can go ahead.
Go ahead, Maria. I will jump after.
Yeah, no, I think there is still room for both studies. So of course we can have studies where we provide a global assessment, since this is what we are interested in the end. But in order, for instance, also to have information to develop objective quality metrics, I think it is still important also to have studies on specific features, because we still need to understand the behavior of the perception on a number of specific aspects. So good for global subjective study, we're going to run now a set of subjective tests, which are also global, but it is also important to understand the perception of something specific. As an example, I made a horizontal motion parallax, but there are other aspects that can be isolated and studied one by one.
So to me, it's once again a matter of use case. So are we planning to use for instance, explore the light field with the full parallax, or is it something where we explore this capability to do refocusing, defocusing? But at the end of the day, yes, we need to work with everything. When we run subjective tests, we should not forget that there are two sources of uncertainties in that particular scenario. There is one source of uncertainty that comes from the agreement between observers, writers. And the source of disagreement can come from many things. It can be their experience. It can be also because some of your observers do not necessarily perform the task very well. And there are also the environment, everything. So this is one source of noise, let's say noise and uncertainty. The second source of uncertainty is that either you let your observers freely interact with the content, like in the case of Maria, light field on light field display, or either you constrain the trajectory, like the HRT that I was mentioning, and you constrain it. In the case of letting every observers interact freely with the content, then you have a second source of uncertainty because everybody will have its own trajectory. So the question I cannot answer now is that how many observers or raters do you need to, let's say, somehow limit this second source of uncertainty? Or the other option is to go to constrained interactivity, and you select only some hypothetical rendering trajectory, but you are not covering everything, right? And then if you go towards that, how to select the critical one? So the approach is could be to use an existing metric that you trust, generate many rendering trajectory. You are not sure of this metric, you trust it more or less, but then you can select the most critical path for you, the most critical trajectory. The question that we don't have is that how many observers I need in the first scenario to meet the same accuracy that I guess in the second scenario. First scenario, free interaction. Second scenario, constrained interaction. And we don't have this, any work on that. I'm not aware about any work on that. While in the community, people have adopted one of the two scenarios. And one thing that could be very interesting is to dig into that.
Yes, in some cases, what we did was to have a partial constraint. So in one of the tests, as I have shown, for instance, we allowed the user to move in 2 meters in a line in front of the display. So we had marks on the floor. In another case, there was even occurred something that only allowed the viewer to move in an arc in front of the display, so in a specific arc in front of the display, so that the users was always in the field of view, in the appropriate field of view on the display and at the same distance to the display. So there are intermediate solutions. We can leave the user free to move, but with some constraints. And this reduces the infinite possibilities that you mentioned, Patrick, of mobility of the users.
Yeah, before Fernando raised his hand, before Fernando asks what he wants to ask, I'd like to ask Zibo if he also constrained the viewers when he performed the tests.
Hello.
Your position.
Can you hear me?
Sorry.
Yeah.
Hello.
Yes, we can hear
because there's something wrong with my network, so I cannot actually see the video, and also there's some noise in the audio, so I didn't hear very clearly your question. Your question about the subject dataset building for the light field image.
Oh, actually, now it was about if you constrained the viewer positions in front of the screen when you were performing the tests.
Mm-hmm. Then what's the question? If we constrain the viewer,
I will write down because I believe you have a problem with the.
yeah.
Okay. If you have limited the positions or marked the positions of the viewers when you were performing the quality assessment. I will send it to you. You need to establish positions.
Yeah, that's a good question. Actually, okay. From our experience, can you hear me?
Yes.
Okay, because I see you the still image actually, no video now.
Oh,
Yeah.
okay.
Okay. Okay. So from our experience, it's really depend on the what kind of display devices you have. Yeah. If so, I don't know if Professor Maria. I think from your report, you have already kind of light field display, right? So
Yes.
how many, I mean, the angles you can see the such kind of stereo and
This 45
motion
degrees.
parallax?
45 degrees. Can you hear me? 45 degrees. Should I type it?
Sorry, I cannot hear.
I will type it.
Hello? Can you hear?
Yes,
Oh,
I typed
45
it.
degrees.
Yes, yeah.
Okay, sorry. Maybe it's my network problems. Yeah. Okay. So during your subject testing, you have one subject before the display.
Yes.
Yes.
Okay.
Yes. Yes. Yes.
Yeah.
So is it possible to have 2 or 3
Yes,
subjects?
we
at the
can.
same
We
time?
plan to do tests with multiple subjects. Actually, these are part of the test that we would like to do in November, end of October and November. We have some tests that we have planned them for 2 years, and now we finally can do them. And this is part of the
Okay.
test we will do in October, November.
Okay. Okay, interesting. Is it possible to change the angle from in the vertical direction? Or
No,
only horizontal direction?
our displays is horizontal parallax solid display. There are not many
Okay.
displays actually in the market. I'm aware of one with a cost which is almost possible, at least for university. I don't know for major companies, but I'm aware of only one which is in the market, full parallax display.
Yeah.
Okay. Yes. So from our experience, it really depends on the display, what kind of display we have, and also maybe if we want to provide kind of 5 degree of freedom or 6 degree of freedom to the user, maybe we can just as we have done, we can try to produce some software to help some interactive experience for the subject to help to provide such kind of experience. Yeah.
Okay, thank you.
Can you hear me?
Oh,
Okay.
sorry. Do you have anything else to add?
No. Yeah. Thank you.
Okay.
Okay.
Okay, thank you.
Sorry.
No problem. Well, we have Fernando, and then after Fernando, Peter raised his hand. Fernando, please.
Let go, Peter. Let Peter go.
Peter, Fernando told
Okay,
me.
thank you, Fernando.
Go ahead. Yes.
But you are free to ask your question now as well. Well, first of all, I would like to thank all the speakers because these were very interesting presentations, giving a nice overview of a number of issues that we tackle in this domain and actually good practice that existing already. But I think one of the topics, unless I missed it, that was not really covered in detail is actually, and so Maria was mentioning that they're going to do tests on light field displays, is the fact that how do you account for like certain amount of pre-processing and so forth that is taking place in the display itself. So we have also some pre-processing happening in regular displays, but okay, these are less severe in terms of okay, what the impact is on the subjective quality. At least it doesn't have such a severe impact. But for light field displays, there are all kinds of things going on in the display, which can be partially a view interpolation that takes place. But also you have the issue that there are actually several different technologies being used to actually make a light field display possible. You have the ones which are using anisotropic diffusers. There are ones that are making use of lenslet arrays and so forth. So how do you think, and I'm asking it to the three speakers, how do you think that you can account for these aspects, or what should you do to avoid this kind of aspects? Because these are typically issues that raise a lot of discussions. We have experience with that in the JPEG committee as well. And I'm quite interested to hear how you are thinking about it, about this issue.
Yeah, maybe something I can mention is that what we have done until now, we have not compared results among different displays. Because as you mentioned, there are a number of processing going on into the display that it's not easy to compare results of subjective tests performed on different displays. As long as we compare results on different impairments on the same displays, this issue appears, of course, but it's not major probably. I would see it as a major issue if we want to compare results between different displays. For instance, displays using different rendering techniques, using different interpolation methods on the views. So we have not focused explicitly on this since until now we have always used the same type of display. Now we will start to use in a different displays because the studies that we did in the past were done on one display. Now we start using our new display. So this issue may arise if you want to compare the new results with the old ones, for instance.
The reason why I'm asking this question is also because, okay, in the end, when you're looking to a standard, particularly when developing a coding standard and so forth, so the target is always to create interoperability. And so that means that if you want to encode your content in such a way that you can serve many different types of displays, because that's where you're going through. I think if the light field display market is further evolving, you have in one way or another try to account for this, or not to account for this, but then that means also at the level of the subjective quality testing and quality testing in general, somehow you have to bring this into the equation.
Yeah, this is definitely something that can be studied in the future.
I would like to comment on this, and based on the principles that that we adopt for coding, standardized of codec or quality metrics. One rule of thumb is that you need a transparent display. This is the purpose of your test plan. I started to work with a light field display on my side in 2008-2010. Since then, a lot of progress has been made, but still, we are far from a transparent light field display, according to me. And it is still valid to work on that, as Maria did, because we need to develop transparent display and we need to develop the best light field displays as possible. And this requires to do all these tests and everything. But when it comes to, let's say, as you mentioned, Peter, find all the possible use case of exploding light field possibilities, still light field can be exploded on 2D display. And we have many 2D transparent display. This is why we can refer to this pseudo video, pseudo interaction, playing with parallax, playing with focus, like the video I presented in my presentation. So on my side, when it comes to develop the metrics as general as possible and benchmarking codec, I don't want to be a slave to a non-transparent display. So unfortunately, these days, the work that we are conducting are mostly the exploitation of, let's say, light field planoptic on 2D display, or can be stereoscopic display eventually, or VR, but we are kind of restricted to that. That's my opinion on that.
Thank you.
I don't know if Fernando wants to ask his question now.
Yes.
Well, to confess, my question was mainly for Maria, because she mentioned that there is this document with the guidelines for subjective and objective assessment coming soon, And JPEG is also embarking in an effort to develop subjective and objective assessment of light fields, the quality of light fields. So in your opinion, Maria, looking to the guidelines that I personally don't know, I'm sorry, what are the use cases, somehow following what Patrick was saying, use cases are important. What are use cases or the functionalities or the conditions that you believe that the guidelines that are coming did not address? So what most important is still not addressed? Can you give us an idea?
It's a long list, actually. It's a list I have somewhere for the extension of it, because you know that the standards can be extended, expanded. I don't have it now with me, but it's an Excel file with many items. So there is still a lot of work to do, of course. I don't know where to start from, but there are many. There are still many elements. We still decided to have this document out because there were no recommendations at all for light field imaging. So we thought it was worth having at least the first version, but of course there are many other variabilities, many other use cases, many other types of tests that can be performed that were not discussed in this recommendation, of course. Mm-hmm. So there is still
it's a pity that I know that the document, I think it's $80. It's not a big amount, but still for academics, when we have a document in this world, when you have to pay $80.
Also, it's still a draft. I noticed that they made it available paying $80. I noticed yesterday while preparing the presentation. This is still the draft, so the official one will be out in October.
It will be more expensive.
To pay $80, pay them in October. So we had
Fernando, I just want to mention that to be part of this IEEE standard effort is not that difficult, actually. You can always become a member of IEEE standard activities. And
no, I understand.
And it's much less than $80. This is what I can tell you.
Yeah,
just to add this possibility on your IEEE membership, and I'm sure you have an IEEE.
No, I understand, but in JPEG documents are public for free, right? As you know, you don't have to pay anything.
You know IEEE world, huh? You know very well IEEE world.
No, I know.
No, but
much of the material will be published in scientific papers, but it's not the same document, of course. But some of the discussions we had and some of the consideration we did will be published soon in scientific papers. So you will find the relevant information soon from joint papers. Patrick was a very active member in it as well. So from his team, my team, and all the other members, you will probably see relevant papers soon out with information contained.
But Maria, if you allow me, it's a bit a nasty question, and it's a bit personal. IEEE has no really long tradition in multimedia coding, qualitative experiments, all these things. Okay, it's clearly a kind of side job. Okay. So what motivates a person like you to go to this type of environment and not to the environment where most of the community for decades has contributed? I'm sorry for the question, but I'm really interested.
I can tell you the story. I can tell you the story of my involvement. I've been involved in a number of standards from IEEE. I was invited by, you probably know, Samgun Lee was chairing a number of standards on 3D in IEEE. At some point, there was a discussion to have a new standard on light field. They asked me to, if I could share the effort, and there was a nice group, a nice team. I knew somebody else who was interested, and that was an opportunity that came to me, not me looking for the opportunity, let's say.
I see.
And I think it was a very good working group. Patrick was part of it, so I think he can say it as well. It was a collaborative environment, which I liked very much. I don't know how standardization works in JPEG. I'm not part of it, but I like very much the atmosphere and the collaborative environment of the different teams involved.
I can supplement that also. That, despite we have a very efficient group as MPEG, JPEG in ISO, ITU community, there were no really effort focus on human factors for visual experience. And that was what mostly appealing in this IEEE standard, that we have really something related to human factors for visual experience. while you know, JPEG, MPEG are mostly focused on compression or multimedia delivery chain and everything. Here, it's really something focused on human factors for the visual experience. So
I understand. You're
yeah.
right. Thank you. Thank you.
And of course, there are some boundary, some overlap between the two worlds, and especially when we start to talk about quality metrics, protocols, and everything.
No, because I think, of course, you know, it would be nice to have a good collaboration, for example. But the fact that it's more psychological than practice, this paying thing, I think a lot of people would not have access because they don't want to pay. And so we are limited by this fact to have a real nice collaboration, because if you cannot have that, I'm not speaking for myself, also other people, if we cannot have the document, it's difficult to understand each other because we don't know what's going on. Anyway, it's life, it's part of life.
But once the standard is public, we can have presentations about what is here. I think it's early to do it now because it's I think that they made the draft public. I realized yesterday, but the standard is not officially. The final version is not officially out yet, and this is why I did not describe some details which are there. But I cited one paper, one of the papers that has been published recently, which contains some of the discussions and information that.
Some for me, most of the things. For me, most of the things I have cited in the presentation are something which are reflected in the standard. I would say, Fernando, the IEEE SI activities are still fulfilling the open innovation spirit that we have in JPEG or MPEG. So it's still open.
Well, it seems more business, Patrick. I'm sorry to say, but it's more business.
I think really leaving it from inside, I tend to disagree with that. It's still open innovation spirit, but it's not open access, and that's the problem. And there is a difference between open innovation and
no, I
open
agree. I totally
and
agree.
that's the main difference. And for this is what you are complaining mostly about. And I can tell you and testify that from inside, we are really in open innovation.
No, sure, by all means, you know, I know IEEE well enough. Anyway, thank you guys for being so open and sincere.
Thank you. Thank you. We are running 9 minutes late. Any other questions? Oh, thank you all for coming, especially our 3 speakers. Thank you very much. And I hope we will keep in contact. I'll ask you for your slides for our proceedings. If you can share, I will email you. So, okay.
Thank you.
Thank you very much.
Thank you.
Bye-bye. Thank you.
Thank you.
Thank
you. Bye-bye.
Bye.
Stop recording.